Okay, so we're gonna do the PV watts review, and the question was, of the three different sites chosen, which one is best and why? So let's go over that again. That's a good question. So PV watts and system that operates, battery, PV modules, charge controller. Because I think what we did, we looked at three separate sites. Okay, this is not it. Give me one quick second. Okay, so I don't have the I don't have it in front of me, but I think I can do it from memory. So let's pull up a new sheet and let's go to NREL. Let's go to PV watts. And I'll go to PV watts calculator. And can you tell me the name of one of the sites? I can't remember. Jesse, can you tell me the name of one of the sites? I'm gonna try to remember. I think there were three, right? There was one in Colombo.
Anuradhapura and
Okay, let's try Andamapura first. So I'll ANURA. Let me get my spelling right. ANURA. DHA. Pura. Yeah.
yeah.
Yeah. Let's try that. Okay, so this is one site. So in PV watts, it found the site. So I'll go to system info, and I think we were doing 1 megawatt, right? So 1,000 kilowatts. Module type, was it standard? I think it's standard. And I think on the array we did 1-axis tracking. 1-axis tracking. And then what was the tilt? Was the tilt 20 degrees?
No, it's 29.
29? And I think we can do this. I think we'll just say it's commercial. Okay. So here's what I did. I have 1,000 kilowatts, standard module, 1-axis tracking, 14, 29, 180. So now I'll go to results. Go to results. Okay, so I'll take this number. I'm going to go back. I'll put it in my Microsoft Excel as a new sheet. And I don't think these numbers are exact as the last ones, but I think they'll be close. So here's this. And then annual energy. So let's just check the results. Okay, 1,607,590 kilowatt hours per year. So we put that in here. Whoops. Copy, paste. All right, for this site. And then the power, this was in kilowatts, was 1,000. Cells, standard, losses, 14%. Tilt was 29. And this was the annual energy in kilowatt hours. Okay, so that's one answer. Now let's go back and try a different one. Sri Lanka. Was this another site here? Trincomalee?
Yeah.
Let's try it.
Yes.
Okay, Trincomalee, let's try that. So we'll go back.
Yeah.
We'll go back to system info. Change location. Okay, it found it. We'll go to system info and we'll do the same. 1,000 kilowatts, standard. Okay, we'll do one axis tracking. I forgot here. Let's do this.
What is that? Tracking?
Yeah, tracking. Let me show you. Okay, so this is one axis tracking right here. See one axis? This is one axis tracking. This is
Okay.
this is the second axis. And you could also have some with both axes. This one has both.
Okay.
Okay, so this one is called elevation. Elevation.
Elevation.
This one is called azimuth.
Azimuth.
Yeah, so I'll show. Let me do this. One axis is typically azimuth. And azimuth is east, west. Typically north, south, or up and down. So if you're in the south, so here's another picture. So this is 0 degrees, 30 degrees, 60 degrees. Yeah. Yeah. So this would be near the equator. If you're near the equator in the south, as you move further and further north, it has to be greater angle. I can show you one other picture. Courses. Note 2. Chapter 3. Okay, let me just show you. Oh, shoot. Sorry, I thought I had something here. This is basically the tilt. I'm sorry, I thought I had a better image. Anyway, so normally, if you can, I don't know if you can see me okay. As the sun comes towards you, this would be the east, and this would be the west. So one axis tracking would be a panel that tips from the east to the west. And then the second axis would be something that tips from the north to the south over the course of the year. So in general, you want the panel to face right at the sun. So that's what the one axis is. Okay, let's go back and finish this problem. So I think we were in Trincomalee. So one axis tracking. You could also say it's just fixed, which is simple, or fixed on the roof, but we're going to use the one axis. And the system losses, that's just from heat and line losses. The tilt is 20 and the azimuth is 180. So let's try this one, Trincomalee. Oh, that's good. So type that in. I'll go back to my table. Oh, look, I think I had a different number here. Let's try this. So this would be better. The Trincomalee would be better, but I think it's because I changed my angle. Let's try this guy because all of these three numbers were the same. This is one axis. These are all the same. I think maybe I changed this number. Let's look. Give me 1 second. I have to clean this up a little bit. Let's do it like this. Copy, paste. So we'll do 29 and 20. And then this was for 20. Sorry, I'm moving kind of fast here. This one, let's delete that. Okay. So we did enter Padura at 29, and we got 1.6. We got Trincomalee at 20, and we got 1.7. Let's keep everything else the same. Okay, so let's verify. Trincomalee 20, 1.7. That's the result. Trincomalee 1.7. Let's go back to system info. And let's put in 29 degrees.
Yeah, now 28.
Yeah, and it's a little less. It's a little
Yeah.
less. Let's put that number into our spreadsheet. 29. So it went down. And let's go back to Annapurna, copy. Okay. System input. Resource data. Change location. Go. System info. Okay, 20. Let's verify. Let's do 20. Everything else is the same. Go to results. Okay, a little different. So you can see in both cases, 20 degrees is a little bit better. All right, so this is good. It's a little bit more, so I'll put green there for good. Green there for good. And what we can also do, watch this. I'll put in a function, rank. Maybe you don't know rank. It'll be this number of these cells. Let me change this. I'll change this. And now I can take this copy, paste, paste. Do you see what I did there? I had each of these 4 sites. Let's just do this. Merge and center. Merge and center. And so I can see this is the best one because this is the biggest number. Let's go a little bit further. Let's try a couple more. Let's try a couple more. Let's try another number. We'll try to maximize it. So let's try a tilt of 15 in both cases. Each of these will be the same. We'll just use the same each time. So none of this will change. This is all the same. We'll just take this, copy it, paste it. Okay, so the only thing that changes is our degrees. Degrees is the only thing that changes. Okay, now we need to know this number, and we need to know this number, and this one, and this one. So I just added 15 and 15. So let's go back to PV watts and see what happens. PV Watts. Where are you? Where are you, PV Watts? Come in. Okay. Go to System Info, and we'll change this to 15. Annapurna, 15. Everything else is the same. Go to PV Watts. Here's the answer. Not much difference. So for 15, here's that number. I'll do copy, paste. And let me just check this. Oh, I need to drag it all the way out. Copy, paste, 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 paste. Okay, this still needs a value, so I'll change this back. I'll change this back. Change location. Trincomalee, go. Okay, that's good. System info. 1000, standard, one axis, 14. We'll change this to 15 degrees. Go to results. Ooh, that looks good. Copy. Paste. Ah, that's the best one. See, that's the best. That's the best one. Number one.
Yeah, then the energy consumption less. Degrees went less. Annual energy is higher.
Yes, that's exactly right. When the degrees this, but maybe we still need to keep going. I think maybe even flatter is better. Let's check. Let's check. Let's do 10. And we'll do 5, and we'll do 0. Okay? See what I'm doing? We'll just keep going. We'll just keep going. Do you like Microsoft Excel?
Yes.
It's good. I think it'll be your friend. Okay, so let's keep going. So 10. System info. Let's try 10. Woo! Even better. Even better.
Don't hide
Yeah. Even better. Okay, let's do copy, paste, paste, paste. Okay. We still need this, and we'll do 5. Let's go back to 5. Go to a calculator. Maybe better. We'll see. I don't know. Wow. Little bit better. Gosh, maybe flat is the best. This is surprising. Okay. You're very close to the equator. This is why. Very close. Maybe we'll just go 0. Let's check.
less.
A little less. Ah, okay. Okay, so this one is, so 5 degrees we found is the best. Whew, okay. All right. Now let's let's take a little break here, and then I think we should do batteries, right?
Okay.
Okay. So thank you for that question. This I learned a lot too, because we can see that in Trincomalee, there's in general, with everything else the same power, same cells, same axis, same losses, that the sunlight is a little bit better. You know, we could just say equals that number divided by this number, or no, let's do it this way, equals this number, 7% better. We write this as a percentage, right? 7% better here. And we can also show that with the with these guys, each time we could even plot it. This is kind of fun. Maybe. Let's see. Insert chart. I don't know if this will work or not. Yeah, look. See, look. 5 degrees is the best.
Yeah.
Very cool. Yeah. This is good for Microsoft Excel. It shows it's modeling. Oh, I love it. I love it. Okay. We'll take a pause here, and then we'll do a little bit of batteries, and then I have to go.